So last time we met was in February, and I think like 20 some days ago, I took the time to kind of redesign our website so it doesn't look like it's from the early 2000s anymore. Nice banner. We've got a nice nav bar now. Um, as always, you guys can always find the Constitution. There's news up here too. I try to post all the news from just like the due dates for if you guys are doing the ACSL contests. Um, some resources. Just these are just the links to the wikis. Uh, if you guys if you guys are doing ACSL, you should have received an email from me earlier today with the resources that, let's see, yeah, with a big list of resources that you guys can study, and some practice tests from last year's test, and then yeah, so we have club news here. The resources, this hasn't really changed, just looks different now. All the content's really the same, it just looks newer. The font's different, the color scheme's different. As you guys know, all the meetings are posted here, and I put the resources that we code also on GitHub, so if you guys want to check that out, the PowerPoints, you can download those and then watch the meeting recordings. And if you don't want to sit through like an hour recording, I usually splice the like the tutorial sections of our meetings into individual, like usually 5 to 10 minute tutorial videos. So you have all the Python object oriented stuff that we did last time: set, get, string, constructors, classes, objects, attributes, methods. So you guys can run through that if you're interested. If you ever missed the meeting, you can always just rewatch the meeting through our meetings tab. So yes. Also, if you guys were curious, we do have a GitHub where we have code repository. There's not that much stuff here. We just have like the tic-tac-toe game that we worked on, the learn.py, which is just like the basics, like for loops, first functions, uh, variables, stuff like that. And then the airplane class that we worked on last meeting is right here too, if you guys want to check that out. So, oh, and also if you scroll down, you can check out the repository for our website. So all these files, the website is directly run from these files here. So if you guys, it's not the most organized, but every file, every CSS, HTML, even the PowerPoints, the pictures, the PDFs, they're all in the repository. And the way that the website's set up, the web server just reads off of the files in here in the from GitHub, and it just builds the website that way. So if you're ever interested, this is always up to date. You can check out what kind of like how the website's built, HTML files, the CSS files. So if you're interested in web development, the CSS is a bit of a mess, the way the styling is set up. So if you have any questions, you can email me or just text me on Discord. Okay, so that's the website. New stuff for the website, and if you guys want to check out the code for the website. So going on to the main topic of the day. Oh, those are my emails. Okay, so we went over, last time we went over, if you guys missed it, we went over object-oriented programming in Python, which we just went over the difference between functional programming and object-oriented. Went over like how to create your first class, method, and objects with our airplane class. I think William, let me just let William know that I think he's hopping in later, that we are on Discord. Okay, anyways, so we just kind of went over the differences, and I told you guys about abstraction, inheritance, polymorphism, and encapsulation, and like kind of why this is the reason why we use object-oriented programming. I guess I can go in slideshow here. Let's see. This is the wrong screen. 1 second. All right, there we go. So we talked about why we did that, and I kind of just glossed over some of these terms. So we'll go more into encapsulation, abstraction, and also inheritance today. And like at the end of our lesson last time, we went over kind of setters and getters, and there wasn't really a reason because we had just public attributes. So like you could just access them outside the just in the main with a dot whatever attribute instead of using a getter, or instead of using a setter to set that attribute. However, we're going to talk about more private attributes which require setters and getters to access and set out in the main. And then we'll go over some very basic inheritance. So like we'll use our airplane class for single inheritance. Oh, I guess we can go over this. I can go over inheritance, but so we'll do some simple inheritance later on. And I'll walk through the code. It shouldn't take too long. Probably be done in like 30 minutes. But inheritance is kind of where you can use there are parent classes and child classes, and you can use a class that you've already built or a class that someone else has built to create your own classes, your own child classes that inherit the attributes and methods from the parent classes. So to go over a kind of a more macro level explanation, you can create a class for mobile phones, for cord phones, for earplugs, stereos, and then they would have a parent class of phones and sound systems, which would also have a parent class of electronic items. So you could say a mobile phone is a phone, which is an electronic item. So that's kind of what we'll be working on today. And mobile phone will obviously inherit all the attributes and methods of electronic items, and also it will inherit the attributes and methods of phones here. And kind of you can have multiple layers. So you can have kind of like here where it's inheriting all the way to electronics. You can have a child class inheriting from a parent class, which also inheriting from another parent class. So parent classes are also called superclasses. So if you hear that, that's just a parent class. You can also have a child class inheriting from multiple superclasses. And then we'll use our airplane class to kind of make a child class of biplane, because a biplane is a kind of airplane. And then we will, for like multi-level inheritance, we will use just very basic a parallelogram, and then a rectangle and a square class. Obviously, we can do this because a square is a parallelogram, or is a rectangle, which is also a parallelogram. So there's kind of a hierarchy here. All right, cool. So that's the explanation of. Let me just check. I don't know if Mr. Sarko emailed me. Okay. Nah, it's okay. No worries. I think he was busy. All right, cool. So that was that's kind of the basics of inheritance, and then we'll write some code so you guys can kind of see it in action. So this is where we were. Oh, you know what? Why don't we do the private versus public stuff first, and then we'll get into inheritance. So here, let me delete this. All right, great. So here was our class from our airplane class from last time. I deleted some of the other code that we wrote because it's not useful here. But here was the airplane class that we had. We had a wingspan attribute, model attribute, passenger capacity attribute, location, and a fuel attribute. And we can probably actually simplify this. You know what? It doesn't really matter. All right, so right now all of these attributes here are all they're all they're all public attributes. So what that means is, if say we created a plane here, we'll name it just plane. Oh. Okay. By the way, the good thing about coding in IDEs, you can easily rename your variables. So we have a plane attribute. It's just we call it an Airbus A380, wingspan of 350 feet. Its location is London. It has a fuel of 3,500. So if we wanted to access one of the attributes, say like model, we could just do print plane.model, and it will give us, oh, sorry, this is the wrong file. All right, it will give us Airbus A380. You can see down there. However, sometimes when you're writing code, you don't always want your user to be able to access the attributes. Like model, yeah, sure, that makes sense. But sometimes there are attributes that you would only need to use inside of the class. A local attribute, right? And you might not want your user messing with it or changing the value of it. Say you could have like a ratio of planes in the air to planes on the ground or something, but you want to keep that constant. You don't want your user messing with it or anything. You wouldn't want your user just being able to go plane.model equals and then just changing the plane to like a Boeing 747. Because if you do this and you print out the plane, it will change to Boeing 747, and you might not want that as a designer, as a software engineer. So what you can do is you can create, say let's make model. We can change model. You can refactor. You can rename it, and the way you can tell it's a private attribute is you have two underscores in front of it. So if you press refactor, it just names all the other models to underscore model. So when you see this, you now know that model is a private attribute. So if we try to access it, say, so right now model we haven't, it's just be Airbus A330. And if we try to access plane.model, it gives us an error because it thinks that it lies to you, and it says that there's not an attribute called model, because obviously there is an attribute called model. It's here, but it's private, so you won't be able to access it from outside of the class just by doing this. And that is kind of the first part of data abstraction, right? That's information hiding. You're hiding the information from your end user. If you don't want them to access model, which you probably would, because that's pretty useful, but you can have say if you didn't want to change some some internal numbers that you're just using for your methods on the inside, just to make the calculations work, and you don't necessarily want your user to change that, you can make it private. So the question would be, how do you change model and how do you change plane from outside of the class? Because right now, if you did you can't even access it. So if you even tried changing it, it wouldn't work. plane.model, and if you tried changing it to something, etc., right, it wouldn't work because it's private and you wouldn't even be able to access it. So what you do is what we reviewed kind of at the end of our meeting last time, which was the get and the set methods. So right now we have a get and set for wingspan, and we can just copy and paste that and then just change the wingspans to model, and then this is also model. And now you'll be able to access it using the get, this would be changed, get model and the set model methods. So those are your getters and setters, and that's the real reason you would use a getter and setter, and that would help you encapsulate your data. So that's kind of encapsulation for you. Very simple explanation of it. And just to show it works, obviously if we run this again, nothing's going to happen. So if we want to do plain dot get, or get model, if we do it this time, we'll get a response. And then if we say want to set that to something, plain dot set model, and then we can set that to what we had before, which was Boeing 747. And then there you go. So you've declared a plane, and you set to initially the attribute to Airbus A330, and then you turned it by using set to Boeing 747, and then you printed it out by using the get method that we wrote before. So those are private attributes in Python. There's also something called a restricted attribute, which is just one underscore, and you are able to access that outside of the class. Out here, if we did, you should be able to. Let's just see, plain dot underscore, what do we set it? Passenger capacity. See, it would work, but see, it's yelling at me a little bit. You're not supposed to access it. It's kind of a warning that you're not supposed to access it outside of the class. So you can do it like I did here by just printing it without a getter, but it's just kind of yelling at you not to do that. So there you go, private, public, and protected attributes. All right, great. So that's done here. All right, cool. So now we can move on to inheritance. Does anyone have any questions on getters and setters and private attributes and encapsulation? I see William is here now. No? All right, awesome. Not too complicated. Basically, if it's private, can't access it outside the class. If it's public, can't access it you can access it outside the class without a getter and setter. All right, great. So why don't we create a new class, and we'll make this we'll call it biplane. And the way in Python that you signify that biplane will be a child class of the superclass or parent class airplane is you just put inside the parentheses, or when you're creating usually you don't have parentheses, but when you're creating the class, you put in parentheses after the class, you just put airplane. And now you have a class biplane, which is a child of the superclass airplane. And you can just write pass, which doesn't do anything. It's yelling at me because there's no spacing. But just to kind of show why is this yelling at me? I think it's missing a space also. Okay, just to show kind of what a child class does, it will inherit all of the methods, so all of these methods that we've written, and all of the attributes of the parent class. And we'll get to method overriding later, and also yeah, method overriding. But right now we can create a biplane. So we'll say we'll just call it biplane, it doesn't matter. But biplane gets, and we're creating an instance of the biplane class here, creating a biplane object, right? And if you can tell that there's nothing here, so all it's gonna do is it's gonna go to the default. It's gonna go up here and use the constructor of the airplane class, the parent class. So let me know if it gets a little confusing. So right now there's nothing in biplane. We'll add stuff to there later, but we can create, if you guys can see here, it's asking for all the methods of the airplane class. So this is a little extensive. Why don't we get rid of, we don't need fuel. Yeah, so we don't have to do anything. I think if we just, yeah, for spaces. All right, right now there are default like attributes that I've entered in, so you don't actually need to enter in anything, but you can enter in like the wingspan is, say, like 35 feet, because a biplane's a lot smaller than a regular plane. And you could do biplane dot wingspan. As you can see, even though this is a biplane object, like obviously it's no longer airplane. We used to call it, when we were messing with it before, the objects used to be called airplane, right? This is now a biplane here, but it still has the attributes of airplane. So we can do biplane dot print, or yeah, wingspan, and this will give us the wingspan of the biplane. Oh, you know what? I spelled wingspan wrong. My bad. There we go. 35, because we assigned it a wingspan of 35. We can also access all the other ones. Right now there's nothing in model, so. Oh wait, you know what? We made model a private attribute. Here we'll just do location, and there won't be anything under location because we set it as nothing so far. But the point is you can create, I'm just trying to show that biplane will inherit, since it's the child class of airplane, will inherit all of these methods and attributes, so that you can, you don't need to write all these again if you're creating, say, like multiple kinds of airplanes inside of the airplane class. I guess you can even make a helicopter or something. It's kind of an airplane. But you won't have to rewrite all of this. So it really, it helps you reuse code in the future or it helps you, say you don't necessarily need to write all of these. Someone else can write these and you can just use their class when you're writing your own code, which is really one of the reasons why you can use Python for everything. All right, anyways, moving on. Right now, obviously biplane doesn't do anything. So we want to add some functionality to biplane. And to do that, we need its own constructor, right? We need to create, using the init method, we need to create a constructor. So, I spelled init right? Yeah, okay. In this case, what kind of attributes do we want to give biplane? Doesn't really matter right now. We can keep it the same. However, we are kind of overwriting the this is the parallelogram class and the rectangle class that we'll go over in a second. But right now we are kind of overwriting the default constructor here. So we need to give all the same attributes again. And then because we want to give this a since it's class airplane, we want to include the airplane constructor inside of the biplane constructor, because we'll add on to it in the future. But for now, we need to use because we also need to create an airplane while we are making a biplane. It's kind of confusing, but you just need to create an airplane also, because by writing init twice, because it's also going to inherit init here, but by writing your own constructor, it's overriding. It's called method overriding, but it's overriding this one. So for now, we want to keep it the same. So you can do airplane dot underscore init. And then you can include basically all of these inside. You wouldn't need the selves. All right, bear with me for a second. Okay, let me just check. What's the error? Okay, got it. So let's see. We don't need any of these. Okay, why is it giving me an error? Let's see. Are we missing something? Oh, here, there's an equal sign. All right, terrific. There we go. That was weird. All right, so and right now we'll do it this way. We can use super in the future, which is the better way to do it. But what we're doing here is we are creating a constructor for biplane, and we're using all the same attributes, and then we're putting them into the constructor. We're using the airplane class here, and then the constructor from airplane, and then we're putting all of these parameters inside the constructor to create into the parameters of airplane. Which is kind of confusing, but we're just creating we're using this to create an airplane. But because we want to use the airplane class, but we want to extend the functionality of it. So we could have also in biplane, we can have, say, like, what's different from a biplane than a regular airplane, right? The number of wings. And then we can set that equal to 2. Obviously, you might not need a biplane class, but this is just to kind of go off of what we built last time. So now we have an attribute wings 2, right? Which is not in the original airplane class constructor. We are extending the functionality here. So we need to create a wings attribute inside of biplane. So we would do self.wings gets, and then just wings. And this is a parameter, so you can change it. You can even create, I guess biplane wouldn't be the greatest name, but you can create like 3, 4, 5, 6 winged planes if you want to you know, really adjust it to your liking. This isn't really useful. This is just for demonstration purposes. Anyways, now that we've created like its own parameter here, we could create another method that would just print the number of wings, and then this would just print wings or self.wings, right? And now we can test it out. We can run the function num wings or biplane dot num wings. And then when we run this, it'll give us 2. So that whole process was kind of just to show you can create a airplane. You can create its own constructor, and then use the airplane constructor inside of it, but you can add additional functionality to it. So it retains all of these methods and attributes, but we can just add on to it wings. So you wouldn't have to rewrite all of these again. Obviously this isn't terribly useful, but you can print like wings. You can print inside of this function, do a loop-de-loop, and then when you run this again, I'll say number of wings 2, and then it does a loop-de-loop, because biplanes can do a loop-de-loop. At least we'll say they can. And that's kind of how you would write this is a child class of the parent class plane now. And in the future, instead of writing airplane, you can just write super. There's a super method, and all super does is get rid of the instance there. Super will reference the parent class of whatever your child class is. So this will yield the same functionality. And you don't have to only use super when you're using the constructor. You can also use super to access any of the methods up here from airplane whenever you're creating your method in the future, your methods inside of a child class. So this is the real basics of it. Does anyone have any questions on this? Is anyone confused? There's not really a reason for what we did. It was just to show that biplane, the child class of airplane, will have all of its methods and attributes. And then we can add functionality onto it by adding wings and creating its own methods. And by the way, when you create, like I said, when you create another method with the same name as its parent, you are overriding the method. So we can overriding the method in the parent class. So we can do kind of the same thing. Say like fly airplane, or you know what? Why don't we? Yeah, say fly airplane. If we just copy and paste that, we can have fly airplane inside of our biplane. We are overriding the one above, and we could change it if we want to. Say fly airplane, new location, and then well, why don't we change, I don't know, I guess the passenger capacity wouldn't change, but we can have, I don't know, we can just say the wings change or something. Or, you know, it doesn't even matter. We can have that, and then we could just print out this is the overrided method. Okay, let's spell that right. There we go. This is the overrided method. Why is it yelling at me? Typo. Okay, it doesn't matter. I think I spelled that wrong, but we can do biplane dot fly airplane and then give it a new location, say like Chicago. You know what, why don't we print out the self.location again. And then we'll set it as, right now it's set to nothing. So we'll set it to Chicago, and then if we run that, it will give us the new location. Previously, it just set a new location, didn't print anything out. So when we call fly airplane on biplane instead of on the airplane object, it lets you know that, well, we let it know that it's going to print a new location, and then this is the override method. So instead of just changing the location, now it has some extra functionality here specific to the biplane class and the biplane objects. Like, for example, we can create an airplane using the airplane class still, like, no problem. Right, and then we could call this again, and then flying the biplane here, airplane. So we'll change this to Washington DC or something, and when we run that, it's only going to print this is the overridden method from Chicago, because inside of our original airplane method, fly airplane method, we never printed anything out. But if you want to check what the new location of airplane was, you could just do airplane.location, and then it'll say it's Washington DC. So now we have, inside the child class, we have a method of the same name but different functionality. And when you call this method on a biplane, it does something different than when you call it on an airplane, because you've overridden the original method inside your child class. Okay, there we go. That's method overriding. Done with that. And there's a method you can write is subclass to check if we'll say, like, why don't we do, we'll just use our biplane and airplane. So this should print true. Yep. See down there, it's true, because biplane is obviously a subclass of airplane. And by the way, guys, we've created our own classes here, but all of this airplane is also a subclass of the object class. So if you want to kind of see, and everything's a subclass of the object class. It's gonna work. Yeah, this should work. Yeah, there you go. True. Because everything is a subclass of that. If you were to do like well, literally you could put anything here. You could put a string, you could put a list, you could put an integer, and they would all be a subclass of the object class. Obviously, if you were to reverse this, it would, oh, you know what? It's printing true. Oh wait, no, this is the way I had it before, my bad. Sorry, I didn't actually reverse it, even though I said it would. Okay. Nope, spelled my plan wrong. And there you go, it would say false. Obviously, airplane is not a subclass of biplane, it's the other way around. So biplane is a subclass of airplane. So that's how you can check. And there's also a method called isInstance of to check if, say, like, biplane is an instance of the airplane class. But that one's, pretty self-explanatory. Anyways, so that's just your bog standard single inheritance. It took a bit of a while, but we can look at using 3 classes. You can look at multi-level inheritance, and I've created a parallelogram class here. All right, parallelograms have a base, a side length, and then a height. Um, Obviously, the base is the same as the top base, and side length is the same as the side length. But inside of a parallelogram, they have an area, they have base. You can create a setter, because we wouldn't need this right now. And just to kind of show the functionality of inheritance, you can use the parallelogram class and create a subclass, a child class called rectangle, because rectangle is a parallelogram. And inside here, this is kind of what we did at first. You can use super here, which is what you should be doing. All right, get rid of that. And so parallelogram originally has 3 parameters inside of the constructor, because it has 3 different attributes, right? But inside of your rectangle, you only have the length and the width. You don't need to worry about your side length, because the side length is just the same as one of your width or length or widths. So you can assign the new this is kind of confusing, but you can use, this is, the super is referencing the parent class constructor up here, and then it is filling into base, side length, and height. It's making side length and height the same thing. And you can even create a diagonals. You can create a diagonals method. I don't know if you guys want to do that now. It's kind of taking a while. But obviously, in a parallelogram, you don't really know, depending on the kind of the angle of the sides, you're not really sure what the like diagonals are. But a rectangle, it's all got 90 degrees, so you can just use Pythagorean theorem, then bada bing bada boom, and you can calculate the diagonals of your rectangle, and then that's extending the functionality of your parallelogram by creating a rectangle now. And just to show that, we'll get rid of this for now so it doesn't throw us an error. You can also use the square to make cubes and stuff, but we don't really need this. If you want more, I can show you. I can send resources. I'll put links to resources under the meeting video in the website. But anyways, we can create a rectangle, just call it rect and rectangle, and we obviously have to give it a side length, so we'll give it a side length of 3 and 9, and then we can print the area of rect. Even though rectangle itself doesn't have a method for area, it will look at the parent class, and there is an area. So what is the area of a rectangle of 3 by 9? Oops, sorry, wrong file. Oh, you know what? It's giving me an error. 1 second. Let's see. What is the problem here? With let me see. This should work. With print rect. Oh, you know what? I forgot the parentheses. My bad. All right. There you go. 27. That's the area of a 3 by 9 triangle. Obviously 3 times 9. And then you can also create a square class, which is as you can see here, it's a child of the rectangle class, which is also a child of the parallelogram class. So you have like a grandson, father, and then grandpa right there, kind of, if you want to think of it that way. And obviously a square only has 1 side length, so you square and then say 9, and you have access to all of the methods and attributes inside rectangle, which also has all the attributes and methods up here. So basically you can also call area on here. And you get 81, because 9 times 9 is 81. So That would be multi-level inheritance. And like I said, you can add functionality like we did in the biplane class. There's not really much added functionality here. It's just that you have to input less stuff into your squares and your rectangles because you no longer need some of the attributes up there. And that's about it. And that's super allows you to reference the parent class. Does anyone have any questions? You can also do squared out perimeter, obviously. And this would be 36 because 9 times 4 is 36. But it is, all you got to know is it is assigning length and then using the rectangle and assigning the length, width, and width, and going up here and then using those attributes to calculate the perimeter and the area. So that is inheritance for you. You can create classes that inherit methods and attributes and then add on to their functionality. So you don't have to rewrite all this stuff again when you're creating your child methods in the future. And that's about it. Does anyone have any questions? Sorry if it's a little confusing. As you do it more, it makes more sense. But it's a little confusing when you first start off. These are very basic. If you guys want to mess around and add functionality, I'll put the code into the GitHub, and also I'll put a link into our website. William, you want to add on anything?
No, I think you covered everything.
Yeah.
Are we doing like game development next?
Oh, yeah, exactly. Good. Thanks for bringing that up. Yeah. So I think we've covered most of the basics of Python, and actually I think we've gone a lot deeper into kind of the computer science like fundamentals than we really had to for some of the stuff that we can do with Python. So I'll leave it up to you guys what you want to do next with Python, because I think learning the fundamentals is cool, but it's kind of boring, obviously. So you guys want to make games, or we can even learn web development with HTML and CSS. I could probably teach that. We could do, yeah, it's really up to you guys. Any ideas? Would you like me to create a poll?
Yeah, let's just do a poll.
All right, sounds great. Terrific. All right. Yeah, that's about it for today's meeting. Thanks for joining, everyone. And I'll put as always, all the resources and everything will be on the website. And we will be moving on from Python basics. I think we've covered it all. Yeah, even into some more complicated stuff. Probably won't even, we'll probably use classes in the future again, but we might not use inheritance and stuff. But just so you guys know what it is in the future, and so you can have a kind of basic understanding of it when you do take more advanced computer science courses.